Good morning, students. Once again, I welcome you to my second session, second class on control systems, video lectures. And yesterday, I was giving introduction to root locus diagrams. In root locus diagrams are extensively used in the design of control systems. That is, design of controllers. Very useful concept. And today I will continue with the basics because to understand the theory of root locus, the knowledge of phasors is very essential. And in the last class I explained that the characteristic equation roots keeps on changing because characteristic equation is going to have a factor called k, and that k is varied over a wide range from 0 to infinity, and tracking the path of each and every root results in a path that is called as a locus. And the locus, the values of k for which the locus remains in left of plane, the control systems are, those control systems are going to be stable. Now today I will continue with Phasor algebra. Now in control systems we have transfer function as for a Cs by Rs, for a feedback system Cs by Rs equals k gs over 1 plus k gs hs. In the last class I told that the forward path element is kgs and the feedback path element is hs. So characteristic equation is 1 plus k gs hs equals 0. So gs is a function of s, hs is a function of s, and k is a constant. And it keeps on varying. It is a real quantity k, and k is varied from 0 to infinity. That is called as a root locus. Suppose if you take negative values for k, it is called as complementary root locus. In the case of complementary root locus, k is varied from 0 to minus infinity. In your syllabus you have only root locus, not complementary root locus. Complementary root locus is quite opposite to real root locus. Now k is varied over a wide range, and now I will start giving you the basics. Phasor algebra, you are supposed to, because gs, hs, they are all functions of s. For example, gs can be s, gs can be 1 by s, 1 by s, or 1 by s plus 1, is it not? So what is s? S is what is called as complex frequency. So complex frequency is represented like this, with the help of two mutually perpendicular axes. This is called as real axis, sigma axis, j omega axis, that is imaginary axis. This is what is called as S plane, two-dimensional S plane. So S can take any value here. For example, if you join this point with origin, this is what is called as S phasor. And S phasor in polar form is represented in this fashion. This length is what is called as mod S. And this is what is called as inclination. Always inclination is with respect to positive real axis. Now how do you represent this? S is represented as mod S angle theta. Now this angle is measured in anti-clockwise direction, hence it is plus theta degrees. This is what is called as polar form representation. For example, S point is here, then this becomes mod S and this becomes theta. So theta is measured in clockwise direction, therefore it is taken with minus sign, and this is represented as mod s angle theta. Is it not? So this is what is called as you are studying these things in the basics of basic electrical engineering. Now my question is, locate 145 degrees, locate 145 degrees, locate minus 145 degrees, locate minus 210 degrees, 210 degrees. Now 145 degrees, that means at an angle of plus 45 degrees on this line, cut off a length of 1 unit. This is what is called as, this length is 1. This is what is called as 145 degree phasor. 145 degree phasor. 1 minus 45. 1 minus 45 means this phasor. This is 1 minus 45 phasor. Next 1 210 degrees or 1 plus or minus 180 degrees. 1 210 degrees means 180 degree. 210 means 180 plus 30. That means somewhere here 30. So this angle is 210 degrees. 210 degrees and a length of 1 unit. This is what is called as 1 210 degree phasor. 1 plus or minus 180 degrees. So very frequently in root locus you come across 1 plus or minus 180 degrees. 1 plus or minus 180 degree is like this. 1 plus or minus 180 degrees measure plus 180 or minus 180 and on this line. This is what is called as 1 plus or minus 180 degrees. This length is 1 unit. Now I will ask you to locate minus 145 degrees. Minus 145 degrees. How to locate minus 145 degrees? Now first locate 145 degrees. First locate 145 degrees. This is 145 degrees. This is 145 degrees. Now opposite to this is what is called as minus 145 degrees. Minus 145 degrees. So minus 145 degrees is this phasor. Minus 145 degrees is also equivalent to 1. This angle is 180 degrees. This angle is 180 degrees. So 180 degree minus 145 degrees means 135 degrees. 135 degrees. Therefore minus 145 degrees is also equivalent to 1 minus 135 degrees, because you have measured the angle in clockwise direction, therefore minus 145 degrees. So this is one point. Now next is I will ask you, I will proceed further. I will ask you to plot phasors like s plus 1. So some value for s, and you have to, this is also a phasor, s plus 1 phasor. Plot s plus 1 or plot s minus 1 phasor. So every time we don't come across simply s plus 1 factors, s plus 1 factor, s minus 1 factor. So you are supposed to know to locate s plus 1 as well as s minus 1 phasor. How to locate s plus 1 phasor? To locate s plus 1 phasor, I will give you tip. Now take minus 1. Take minus 1. This is minus 1. And choose s point. Choose s point. This is complex plane. This is complex plane. And on this complex plane, first you locate s. First you locate s. How to get s plus 1 phasor? Join minus 1 with this s value. That results in that results in what is called as S plus 1 phasor. S plus 1 phasor. So to locate S plus 1 phasor, we have to join S point with minus 1, and it results in S plus 1 phasor. How to locate S minus 1 phasor? To locate S minus 1 phasor, join S with plus 1, then it results in what is called as S minus 1 phasor. S minus 1 phasor. Now this S plus 1 phasor will have this much length. For example, if this length is x and if this angle is theta, then it is equivalent to x theta, because we are measuring angle in anti-clockwise direction. S minus 1, if this is theta 1, S minus 1 is equivalent to, if this length is y, then angle theta 1. So how to locate S plus 1 phasor, S minus 1 phasor I have shown, but I have not justified. Now I will justify. What justification for joining S with minus 1 to get S plus 1 phasor. Now I will give justification. The justification is simple, you can follow. This is S point. This is, what is this? This is S point. This is S phasor. This is S phasor. Now to get S plus 1 phasor, we have to join with minus 1. Now what is this phasor? What is this phasor? This phasor is minus 1 phasor. If you take opposite to this, that is this way, what is this phasor then? This is simply becomes 1 phasor. 1. So minus 1 is in this way, 1 is in this way. How will you add phasors? Normally to add two phasors, one phasor is base is placed at the tip of the other phasor. So on adding two phasors, we add like this. For example, this is x, this is y, means this is what is called as z. So z is equal to x plus y phasor, x plus y. Very much similar to this. So this is minus 1. If you take in the opposite direction, it becomes 1. So 1 is added with s, then it results in what is called as s plus 1 phasor. S plus 1. This is very, very important. So throughout root locus, we come across locating phasors like s plus 1, s minus 1 phasor, etc. Now lastly, s minus 1 phasor. Similarly, to get s minus 1 phasor, locate first s phasor. To get minus 1, take plus 1. So this is plus 1. Opposite to this is minus 1. I am not changing the orientation. See, minus 1 can be written here or here, anywhere you write. But you are not supposed to change the orientation. Same one I can represent it here at the top. This becomes minus 1. Now this is 1, this is minus 1, this is minus 1. So minus 1 phasor plus s phasor. So that is why I told you join s with plus 1. So this results in s minus 1 phasor. So in this class I explained what is polar form of representation of phasors and how to locate phasors like s plus 1, s minus 1, etc. In the next class I will continue with further topics. Thank you.